Okay, here's a couple graphing problems in the style that you might see on an exam. One thing I'll point out, when you're asked to do these, the questions are very specific. So it's not like, here's a function, have at it. Sorry about that. We ask for very specific things. So I'll walk through some of the things that you might see. So let's start with this one. Y equals, what I'm going to do is I'm going to do the work on this page, and as I work through and find things out, I'm going to flip over to another sheet and build my sketch as I go. So okay, so the first thing we'd likely be asked to find are any discontinuities. We're going to locate them. So division is typically an issue. So we're going to look for discontinuities. I can't allow the bottom to be 0. So I find solutions. Cannot have x equal to plus or minus 1. So these are my discontinuities. Don't assume that these are asymptotes. These will be, but we need to check the behavior via a limit. So I want to check the limit as x approaches 1 of this function. And I direct substitute 1 and I get 2 over 0, non-zero over 0, so that's indication of an infinite limit. So I need to check both sides. So clearly these numerators are positive. Squares are always positive. So if I take something, this is at left, take something, and I could use, maybe I should have, I won't scribble through this, but maybe I will. I'm going to use the factored version of the denominator. It'll make this analysis easier. So one right gives me positive and positive. One left gives me positive and negative. Okay, and then what I'm going to do is the same thing for the other discontinuity. This camera is fighting me, and it's annoying. And now I have a wire in the way. You're probably dizzy. Okay. So I'll do the same with negative 1. And again, I'm going to see that it's the same value. Right? I'm going to have 2 over 0, which is non-zero again. So I need to do both left and right. And I'll write the factored version here. So again, squares are positive, that's clear. And negative 1 right, negative 1 left, minus 1, those will definitely be negative. And negative 1 right plus 1, it gives me a positive. Ooh. So I have a positive over a negative. And over here, I have a negative and a negative. Positive, positive. So I have asymptotic behavior at plus and minus 2. So what I'll do is I'm going to start to add the information. And we have to label, we have to label, we have to label. So I'll label these asymptotes. And I look at, I put 2. I'm sorry, these are 1s. So I look at positive 1 on the right, positive infinity, on the left, negative infinity. So I come here on the right, positive infinity, on the left, negative infinity. And then for negative 1, it's the opposite. Negative on the right, positive on the left. So it might not look like much, but the idea is at the end we're going to piece this together and see what we have. So that's usually step 1. Step 2 is light duty, that's horizontal asymptotes. So I can usually do this by observation. I'm going to sneak it in here because I have sort of limited room. But we have equal degrees, degree 2, degree 2. So the asymptote is at 2 to 1, which is 2 over 1, which is 2. Y equals 2. So I'm going to add that. Let's put it in here. So if you have this labeled, it doesn't have to be beautiful because the information is here. So what this tells me is I need to be out here at the end. I don't know what exactly might happen in between, but I need to be out here and I need to be out here. So I'm going to use the derivative to find local max and min. This is my increasing, decreasing, in max min, first derivative analysis. So my derivative, bottom derivative top, minus top derivative bottom, 2x. Bottom squared. So I want to simplify this, clean it up a little bit. 4x cubed minus 4x cubed. They'll zero out. And I simply have this. So when I set that to 0, I'm setting the top to 0, and there's a critical number. So remember, when you build this line, you want to include your discontinuities because they're breaks. So you can have changes across the discontinuity. It's almost like it's a completely separate piece. So I'm going to use a little logic here. Let's pick some test points. -2, -1/2, +1/2, +2. And I notice this. Squares are always positive, so the numerator will provide the sign of this. Notice the negative out front, so the sign of this thing will be the opposite of the x value. So these two negative inputs are going to give increasing, and the positive are going to give decreasing. Now remember, this is a discontinuity. This is my max at 0, okay? So the information, you want to explicitly state your conclusions here. And there's no minimums, so we say none. And the max is at 0 something. The y values always come from that. And when I put a 0 in there, I get a 0. So we have a maximum at the origin. Okay. So to refer back to this little sketch as a help, right? You don't need to do this on an exam unless it helps. I have this information. So again, this piece I'm increasing. I got to go from there to there. I have this shape. This piece I'm increasing. I'm going to go from here to here. My max, decreasing here to here, decreasing here to here. And I have a beautiful graph. So typically for what we call rational functions, we wouldn't ask for second derivative analysis, concavity, but we don't necessarily need it. Okay, so that's a very typical exam level problem. Okay, there's one. I'm going to show another one, which is a very simple function, but turns out the graph is unique, very unique. So x minus 1 over x squared. So again, I can just look at this and to determine the discontinuity. X cannot be 0. So this is my single discontinuity. Again, we don't assume it to be an asymptote, although this one is. Direct substitute, you get negative 1 over 0. That's non-zero over 0. Infinite limits, we check the right and left again. Oop, I forgot my function. Now again, squares are positive. So I have that. And then 0 right and left minus 1 are going to yield negative values. So these are both negative infinity. So again, what I'll do, now the asymptote is at 0, so I don't try to stick a dotted line through it, but I'm going to label it still. And I'm going to do this to show this negative behavior near 0. Okay, horizontal asymptotes. The degree bottom is higher, so that gives me one at the x-axis, also known as y equals 0. And again, I have this same situation. I'm not going to try to dot the line, but I know, again, what does this tell me? I need to end up here. So anything can happen in the middle, but at the sort of quote-unquote ends, you're out here. So somehow we're getting from these locations to these locations. And again, I'll finish it off with some first derivative analysis. So I'm inclined to think it's very simple and does this. Just this very basic idea. So when I do this, let's sneak it here. I need to, again, include the 0. That's a break. And my expectation is decreasing, increasing. That would give me, this asymptotic shape in this. It'd be kind of boring. But I did this in the other class and found out something interesting. So bottom derivative top minus top derivative bottom, bottom squared. And simplify this, I get what? This is 2x squared plus 2x. So this is going to be, make sure I got my signs right, 2x minus x squared. Yeah, I had to think about that. I don't know why. Okay, so I'll set the numerator to 0. I don't know why I just used parentheses. Factor in x. And I have actually just one critical number because this would yield a 0, and that's not part of the equation, but it's already on the graph. Okay, we have 3 intervals. So let's use, oh, that's a prime. Negative 1, f prime of 1, f prime of 3. Okay, so I'm going to go back to this, and I'm actually going to put the numbers in here this time. So the bottom becomes 1, and then I have negative 2 minus 1, so that's negative. And when a 1 goes in, I have a 1 on the bottom again, and I got 2 minus 1, that's positive. And when I get a 3 in there, what is this? 6 minus 36, negative. So I have this picture. So this is not a min, right? This is a discontinuity. So increasing 0 to 2, decreasing elsewhere, whoop, 2 to infinity. No minimums, but I do have a maximum at x equal 2. So again, excuse me, I want my y value. That comes from here. 2 minus 1 over 4 is 1/2, right? Oh, over here. So I'm going to locate that point. I'll call it there, and I'm going to label it. And I'm going to do this again. I think this is useful for you to see. Oh, I forgot to put my, my asymptotes right here. Okay, so this is what we thought it would be. This one's a little different. So I'm going to increase to the max as expected, but I'm not just going to decrease like this. I have to honor this asymptote. So you're going to just do something like that. So yes, you can. The important point: you can cross an asymptote, the horizontal asymptote. The horizontal asymptotes tell you what's happening out here. This is a break in the action, so they're a little different. Okay, thank you.